Today, let's go behind the walls and look at something that we all depend on but probably never think about: the plumbing in our hospitals. Now, this isn't just about pipes and water. It's what engineers call a safety critical utility. And that's a fancy way of saying it's a hidden network where even one tiny mistake can have absolutely massive consequences.
So let's just start with a really simple question. What's the actual difference between the pipes running through your house and the ones inside a hospital? I mean, on the surface, it's all just plumbing, right? But the answer, well, it opens up this whole world of hidden dangers and really high stakes engineering.
And this slide just lays it out so clearly. At home, right, a plumbing issue is an inconvenience. A leak, a clogged drain. It's annoying for sure, but you deal with it. In a hospital, though, the concerns are in a completely different universe. We're talking about failures that could jeopardize patient safety, that could destroy years of scientific research, or even cause a major contamination event. The stakes are quite literally life and death. All right, so here's our game plan from this explainer. We're going to start by really defining what makes this kind of plumbing safety critical. Then we'll get into the materials they use, how they stop contamination in its tracks, why controlling waste flow is so important, and finally, how it all comes together from the first drawing to the very last test. Okay, first up, more than just pipes. This is where we really get to the heart of what makes this topic so much more than just a construction job. We're talking about a safety critical utility. So what does that term actually mean? Well, a safety critical utility is any essential system where a failure isn't just a headache. It could lead to serious physical harm, it could directly mess with a patient's medical care, or it could completely invalidate years of important scientific work. Everything flows from this one guiding principle. And check out the specific threats here. This goes way beyond a leaky faucet. We are talking about preventing contamination from getting into the clean water. We're talking about stopping dangerous cross connections, managing wild swings in pressure that could wreck sensitive lab equipment, and, just making sure the water itself has a consistent quality for delicate experiments. Okay, let's move on to our second section. How do you deal with all those risks? Well, it all starts here: the right materials. Before you even think about installing a pipe, your first, and maybe your most important, line of defense is choosing what that pipe is actually made of. And this point is so crucial. Material selection isn't just a detail, it is the primary driver of how the whole system performs. It's the foundation. If you get this part wrong, everything you build on top of it is already compromised. So what exactly makes a material the right one for a hospital? Well, first off, it has to be able to stand up to corrosion from all sorts of harsh chemicals. It also needs to be compatible with really powerful disinfectants. The fixtures themselves, like faucets, have to be designed to stop water from just sitting there and growing bacteria. And finally, you have to be able to get to the whole system easily for inspections and repairs, because you can't just shut down an entire hospital wing to fix a small leak.
This brings us to our third section, and it's a huge one: preventing contamination. The best way to think about this is like creating a perfect one-way door for water. The goal is to make absolutely sure that once water is used, it can never, ever flow backward and mix with the clean supply. And the source material just says it perfectly with this quote: "Cross-connection prevention is a cornerstone of medical and laboratory plumbing. It's not an extra feature. It's not a nice to have. It is a fundamental, non-negotiable rule for keeping these places safe."
So how do they pull this off? Well, it's this really rigorous four-step process. First, you identify every single place a risk could pop up: sinks, eyewash stations, you name it. Second, you install the right gear, like special backflow preventers. Third, and this is key, you test everything to make sure it's installed right and working perfectly. And finally, you document every single thing and set up a strict schedule for regular inspections.
All right, let's move on to our fourth section: controlling the flow. This is about the other side of the plumbing equation. What happens to the water after it's been used? Getting the drainage and ventilation right is every bit as critical as the clean water coming in.
And the goal for the drainage system is incredibly specific. It's all about preventing any waste from pooling up, stopping nasty odors from getting out, and, this is the big one, making sure that hazardous waste from different areas of a lab can never accidentally mix together.
And hitting that goal takes incredible precision. You can see some of the key techniques right here. Pipes have to be sloped just so to let gravity do its job. Vents are placed strategically to keep air pressure stable, which keeps waste flowing smoothly. Those U-shaped traps under sinks create a water seal to block sewer gases. And in the highest risk zones, they actually build completely separate drainage systems just to keep hazardous stuff isolated.
And that brings us to our final section, which really ties everything we've talked about together: blueprint to final test. This is where we see how a plan on paper gets turned into a real-world system that performs under pressure. Now, here's a really powerful thought from the source material. You can have the most perfect design, you can have the best materials money can buy, but if the actual installation isn't top-notch, the system is going to fail. It's the skill and care of the installer that makes all the difference.
And it's not just a single event, it's a whole life cycle. It all starts way back in the design phase, where engineers are talking with the hospital's infection control team. Then, during the installation, the focus is on absolute perfection for every single joint and connection. After that comes commissioning, which is just a fancy word for rigorously testing the whole system. And it all wraps up with super detailed documentation so the hospital staff knows how to maintain it safely for years to come.
You know, if there's one big takeaway from the whole process, it's this. In these kinds of critical buildings, testing isn't something you just do at the end to check a box. It's treated as a core part of the building process itself. It is not an afterthought. And that proactive mindset is what guarantees safety.
And that brings us right here to our final thought. The next time you're in a hospital, maybe you're just washing your hands in a clinic, will you think about that huge invisible network of pipes and valves and vents? All of it meticulously designed and tested, all working silently behind the walls just to keep you safe. It's a hidden world, but it's one that's absolutely essential to our health. Thanks for watching.